Hi, welcome to In 5 Minutes. Last type of oscillator is the crystal oscillator. I can say in the communication systems where we or digital applications we use oscillators, we should have very stable output. That is, crystal oscillators provide this stable output. Or if you use the normal oscillator, say LC oscillator, Colpit, in that you have Colpit oscillator, Hartley oscillator, that will not give you the output as stable. So what you can say, for stable output we go for without fluctuating. We want the fluctuations to be less. So crystal oscillator will provide a very stable output. Can say a crystal which is of quartz is mounted between the two plates or between the two metal plates. You have the crystal wafer which is shown over here. The basically crystal oscillator looks like this. Inside that you have a quartz wafer, and this is the crystal. This is the symbol for the crystal oscillator, and inside that you have RLC circuit and CM, that is the mounting capacitance. Values of the capacitors, RLC network and mounting capacitor will see, and the working of the crystal oscillator. Now basically crystal oscillator works on the piezoelectric effect. Can say what is piezoelectric effect? Suppose to the crystal you are applying an signal, alternating signal you are applying to the crystal or piezoelectric crystal, you can say. So this crystal oscillates at the frequency of the input signal. So whatever is the frequency of the input signal, the crystal oscillates at that particular frequency. So that is there. When an alternating voltage is applied across the crystal, it vibrates at the frequency of the applied voltage. So in other words, we can say frequency of applied AC voltage is equal to the natural resonant frequency of the crystal. The thinner is the crystal, the higher is the frequency of vibration. This phenomenon is called as piezoelectric effect. Now this is the diagram for the crystal oscillator. You have two metal plates, and within that you have the crystal, and you have RLC and the mounting capacitance, whose typical values are 3.5 picofarad for mounting. Then CS you have 0.025, L you have 137 Henry and 15 kilos. Now depending on the metal, or you can say device, these values might vary. So for typical values we consider these values for the crystal oscillator. Now actually the characteristics of crystal, quartz crystal, you can say you have F1. This frequency is F1 and the other frequency is F2. Now we had seen this type of frequency response for the twin T oscillator, that is low pass filter and high pass filter. Now if the impedance, can say in this branch, if XL is equal to XC, you can say crystal offers the least resistance. As you know, total Z we have R square plus XL minus XC the whole square. If both are same, your Z will be only R, your impedance will only depend on the resistance and not the impedance of the L and C. So in that case you have the maximum oscillating frequency. The other is anti-resonant, when you have the, can say, parallel resonance or anti-resonance frequency F2, which occurs when the reactance of series leg equals to the reactance of CM. Can say the entire reactance of this and entire reactance of this is same. At that point you get anti-resonant frequency. You can say crystal offers a very high impedance to the external circuit. Here your impedance is low, and at this point the impedance is very high. So this is the working of the crystal oscillator, and how it is there in the BJT. Can see it is connected in this format. The crystal is connected as a series element between the feedback, can say collector is the output, base is the input. So within the collector, this is base. Between collector and base you have the crystal, right? So it is connected between the feedback part in BJT as well as FET. Since in series resonance crystal impedance is the smallest, that causes crystal provides the largest positive feedback. You have R1, R2, RE provide, you know, this we have done in BJT. So all the elements why we have connected, it is written over here. RFC provides DC collector load and also prevents any AC signal from entering the DC. Coupling capacitor to couple the input or couple the output, but blocks DC. So this is the frequency of oscillation for crystal oscillator. So this is the working characteristics, you can say symbol, then piezoelectric effect, everything we have discussed for the crystal oscillator. Thank you for watching In 5 Minutes. For further concepts, kindly keep watching In 5 Minutes.